we are going to cover, first of all, this is a new section of Hackfest where we would like to start seeing OSM in a deeper way so that participants understand what's going on underneath between the components of OSM and also so it's better, so it's easier to troubleshoot OSM when you see an error. So I'm going back to the architecture of OSM, okay? So to this diagram. It's important for you to understand what's LCM doing, what's VCA doing, RO, and everything, so that you start being more independent when operating OSM and knowing how to do things in an easier way. So to provide a summary first, we have a bus interconnecting or providing a means for components to communicate in an asynchronous way. So this bus is provided by Kafka, and that's where a component can say, okay, I'm leaving this message here. If anyone is interested in that message, it can consume and make something about that. An example would be for leaving, for example, you want to instantiate a VNF or want to monitor, get a metric from the system or something like that, and the NBI component, which is the one that exposes the API, can leave that message on the bus, and the components subscribe to that message or to that topic, because the messages in a bus are organized in topics. Takes action and delivers a response. So that response can be read back by the NBI and delivered to the client. So that's an asynchronous message where components are not waiting for each other. They just leave a message and expect the other ones to react. Another way is asynchronous communication, where a component talks directly to another component and it waits for a result. So both kinds of communication between software components are useful for different use cases, but it's important for you to be aware of both kinds of communications. So we have the bus. We have the LCM as the end-to-end orchestrator. So most operations are passing through LCM when they are related to lifecycle management or of a resource. It can be a VNF, or it may even be a VIM, a registration, for example. We will see more details later. So LCM has direct communication with VCA, which is the component that controls the configuration of network functions. So it gets inside the network functions and configures them. Today, our main element there is a UU controller that through the way of charms, which are pieces of software that can manage the life cycle of applications and the state of these applications. Through these charms, we configure the network functions. You will learn more about charms on Wednesday. And then we have RO, which is the resource orchestrator, which provides a way to interact with VIMs and manage everything related to virtual machines. Of course, I'm talking about the VIM layer in a generic way, but in theory, in the VIM, we can have SDN controllers, we can have NFVI managers, but in practice, we call the VIM an OpenStack platform, and the SDN controller is like a separate entity. But RO controls both. I mean, it communicates with cloud platforms like OpenStack, it communicates with SDN controllers, it communicates with WIMs as well. I mean, one that is not virtualized infrastructure manager will be the the wider network infrastructure manager, which controls the inter-data center connectivity. So in general, it takes care of virtual machines, life cycle, and needs of networking needs through SDN controllers. But does everything that LCM instructs it to do. We have the monitoring platform, MON, which collects metrics from the system, from NFBI as well, to show the state of the network functions, and also monitors some connections like the connections to the beam. It monitors the status of the virtual machines as well. And we will keep adding things to MON so that the state of everything that is relevant is captured by that component. We have the policy manager, which takes actions after some state. For example, it can provide automatic scaling in or scaling out of network functions after a metric has passed a threshold, or can just throw an alarm whenever a metric has reached some level. We have a new component here, which is the placement module, which will be incorporated in the next point release, and will add some automated decisions for where to deploy, which beam to deploy given network functions that require has some needs for specific latency or jitter or bandwidth or cost of the infrastructure. And we have the NBI, which provides a way to interact through a REST API with the system. So that API is leveraged by the client of OSM, the CLI, or the dashboard. Both use the same API, and you can use it directly as well. We have the databases. We're missing here the MySQL database, which is one shared by many of these components. We have the NoSQL database, which is provided by Mongo. We have object storage. Depending on the implementation, it uses the file system or can use external storage system. We have Prometheus as time series database, so everything that Mon collects goes to Prometheus and is stored there. We have an authentication module through an internal backend or through a Keystone backend that provides identity management and assignment of roles in the system. So this is, in general, the architecture of open source MANO. This has been shared before, but what is new is these slides where we want to show you what is going on in each operation that you run in open source MANO. For example, in this case, we are dealing with when we first start open source MANO, one of the first things that we want to do is to create users, maybe create a project, maybe assign a new role to a user, and we don't know what's going on inside open source MANO when we do that. So that's what we want to provide in this section. Of course, you won't necessarily understand all the detail that is provided here, but we want you to go back to this section whenever you need to, and to find the details here so you know where to go when you are seeing some error in the system. Okay, that's the idea. So I'm going to go through these slides briefly, but the idea is for you to have it as a guide to go back to it when you need it. So when dealing with the creation, modification, deletion of users, projects, roles, we have the MBI, which receives the call of what we want to do. And then if we are using the default configuration of the system, which is an internal backend for identity and assignment, then all of this identity information is stored in a common database, which is provided by Mongo. So system the system can go and ask for the privileges and the users there in that database. Or we can, by configuration of the system, switch to Keystone, and that provides other use cases like being able to integrate with LDAP for external database of users. And it, of course, has its own database for identity and assignment, or for assignment only. And when I say assignment, I'm talking about roles in the platform, privileges. Okay, so those are the components. And what I would like you to take from these slides is, for example, that concluding that when dealing with creation of users, LCM is not there, RO has nothing to do, BCA has nothing to do, MON, none of these components. So you know where to go when things are not working as you expect. Any questions so far? Okay, I'll keep moving. Just interrupt me if you have any question. When uploading packages, what's going on when we upload a package? When we, for example, do a OSM BNF create or OSM BNF package create, which are equivalent, or we do a NSD create or a NS package create. When we are uploading a package in the dashboard directly, what's going on? So the API call, it reaches NBI. NBI then it translates that call to a package storage in the given storage that we have depending on the installation. So this would be a local file system, a Docker volume, any storage backend provided by Kubernetes, or it will depend on the installation of the OSM environment that you have. And once that package is stored, then all the information from the descriptors is stored in MongoDB, so that you can later query that database and will find everything related to what is in the descriptors of the DNF, of the network service. It will be there. So when we upload a package, we don't need a Vim to be registered. We don't have LCM. LCM could even be down. We don't need the RO. It's nothing to do with that. Then, when we want to start launching network services, we need a Vim, right? So one of the first things we do in OSM is create a Vim. And which components interact with each other when we create a Vim like this? For example, OSM Vim create, and we specify the user password and the URL for OpenStack, for example, or we do this same thing through the dashboard. When the NBI receives the API call, the information is stored in MongoDB. So the Vims are there in Mongo. Then the registration call is taken by LCM, and LCM drives it to RO. And RO stores that information in its database provided by MySQL, because RO is the main component interacting with the Vim. So it needs to be aware of the Vims that are created in the system. And continuously, in parallel, MON is querying the common database to look for active Vims. So whenever it finds an active Vim, it then gets its status directly. I mean, it queries, for example, Nova, or queries, I think it queries Keystone first, I mean, to get a token, of course, but then it queries the list of projects to find that the Vim is valid, that is up. So Prometheus, at the same time, is looking for active metrics in MON. And Grafana is doing the same for Prometheus. So at the end, when you create a Vim, and the Vim is stored in the Mongo database, its status, I mean, its health will be queried, and the metric will appear in Prometheus. I put Grafana here because by default in the Docker Swarm installation, we have automated a dashboard that goes and queries that shows the Beam list and the status. In the Kubernetes installation, we don't have that yet, but towards the next point release, probably, we will have everything unified. And you should be able to see the Beam list in Grafana automatically as soon as you create the Beam, okay? But at least you will have it in Prometheus at this point in time, so that you can create your own dashboard here in Grafana. Okay, so we have more components here interacting with each other when a Beam is created. Then we have the creation of a Kubernetes cluster. This is brand new in release 7. When you create a Kubernetes cluster, since it's not a Beam, it's a platform for containers that can be reside in a Beam or can be independent. It depends on the installation, can relate to a Beam. So whenever we create a Kubernetes cluster, and in the most common case that we have it virtualized in a Beam, I mean OpenStack, for example, then you provide the Beam name. You need to provide the Beam name. Why? Because in this way, we will be able to provide a network name where, so it's easier to expose services and interconnect hybrid network services that are composed by virtual machines and Kubernetes network functions. If you don't have it related to a Beam, this is irrelevant. But anyway, I'm deviating from the main topic, which is what happens when you create a Kubernetes cluster. In a similar way to the Beam, it goes and stores that information in the common DB, then registers through LCM the Kubernetes cluster, and LCM interacts directly with the Kubernetes cluster to prepare a controller component and Helm element to then manage lifecycle of pods, and it goes to VCA to prepare Juju bundles, which is a way to deploy containerized network functions in OSM. So we have these two happening in parallel. We don't have a row here, as you can see. And we don't have MON yet, looking for the active Kubernetes clusters and monitoring, but this will be part of release 8. When we instantiate a VNF, what happens in OSM? What happens is the API call is received, then the information for that network service instance is stored in Mongo. I mean, you have not only the descriptor loaded, but you have now the instantiation parameters that were provided, that were fed during instantiation time. So this is the instance. And then, as soon as the information is stored in CommonDB, the life cycle starts. So this is maybe the main function of LCM to create a network service, right? And if it's a virtual machine-based network service, then it goes to a row, and a row goes to the Beam and makes all the appropriate calls to Neutron, to Nova, if it's OpenStack, or it can go to a public cloud if the Beam is public, or it will go to the VMware components if the Beam is VCD or Bio. So it takes care of instantiation and replies back to LCM so that LCM knows the status and can report it. In parallel, MON is always looking for active virtual machines instantiated as part of VNFs in the CommonDB, and gets, in this case, the active the status of the virtual machine, so that it says up or down for each virtual machine, and that can give us an idea of if a network service is up or down, basically. Then we have a KNF instantiation. Well, we can call it KNF because it's a containerized network function based on Kubernetes. we call it CNF, because Kubernetes is the only way of deploying containerized network functions today. So KNF or CNF today is more or less the same in OSM. When you launch a network service that is modeled for being deployed in Kubernetes, similar things happen compared to the BNF, but I mean, it first stores the network service instance information in the common DB, but then it starts the lifecycle management through different components that are not a row. We have two cases here, two mechanisms for deploying containerized network functions in Kubernetes. We have the UU-based deployment, which uses UU bundles, depending of the model of the descriptor of your CNF. If you're deploying that way, then VCA will take care of the instantiation through the Kubernetes cluster. And if you are doing it through Helm charts, again, that depends on how the descriptor was specified. Then it will go straight to the Kubernetes cluster and deploy it using Helm, which is a tool for automation in Kubernetes. And you will interact more with it on Thursday. So again, under construction, we have the monitoring part to look for active pods and get the status of the pods so that we can more or less know the status of the Kubernetes network function that is roadmap for release 8. Then we have instantiation with primitives. You will learn more about primitives on Wednesday. Some of you already know about them. Primitives are like actions that are run into the network functions so that we produce a new configuration, for example, or some change in our network functions directly. So we have day 1 primitives or day 2. Day 1, they run automated after instantiation. So aligning to the NFV vision, we are not looking only to orchestrate instances and that's it. We want to orchestrate the instantiation of these functions, and then we want to configure them so that they are ready to provide the services that our operators need them to provide, right? So that's day 1. Day 1 are every configuration that is needed so that the network function starts with the basic configuration. And day 2 are on-demand actions that are asked by the operator to request some changes, to request maybe scaling, to request some monitoring of the network function, of the network service. So depending on the type of primitive, we have different components interacting. If it's a day 1 primitive, it runs automatically after instantiation. It runs in LCM. And what it does is mainly, it is the main path through VCA. So through VCA, which is a UU-based, would be a UU-based primitive. I mean, it would be a charm. It would go to the network functions, either if they are virtualized or virtual machines or containerized. It goes and interacts with the network function directly and produce the changes. Okay, so it does so through SSH or by communicating with an API that is being exposed by the network function to achieve this. We have another case which just implements a specific use case through Helm charts, which produces, for example, a Helm upgrade, which is changing the version of the Helm chart, I mean the set of pods that are running in your application, and that's considered again a primitive, and it's more tied to a day 2 primitive. So in day 2 primitives, they are called on demand through the API. They are stored in a common DB, and then they are requested to LCM. So if the day 2 primitive is the main uses the main path, I mean, it's a charm, then it goes through VCA in the same way as the day 1 primitive. And if it's Helm-based, then the specific Helm upgrade case, then it goes through directly to the Kubernetes cluster. Okay, so these are how primitives are run. If you have any problem with primitives, you will not rely in a row, in MON, in any other component, but mainly LCM and VCA. Instantiating with placement. If you instantiate, any of the cases that we already seen, but you use the placement platform, which will be available soon, you will see a demo this week. It's not yet available in the main code. Then before instantiating, it will ask for placement component to provide the right VIMs for instantiation. And then it goes and instantiate through a row or VCA as usual. Okay, so it's like an intermediate step. Instead of going straight to instantiating in the given VIMs that the user wants to instantiate, it goes and asks if that VIM is the ideal or if the placement platform instructs the system to use a different VIM. Collecting VNF metrics. We have two types of metrics that we can collect in OSM. We have the metrics that come from the NFBI, which are provided by the VIM. In the case of OpenStack, for example, it would be by Gnocchi API. In the case of VMware, it would be by VROps APIs. In the case of Amazon, it would be CloudWatch, and so on. So what MON does to collect metrics that come from an API, basically CPU, memory, disk, and networking information from interfaces. It continuously looks for active VNF with metrics. VNFs that were modeled to use metrics or to gather metrics. And this needs a specific information in the descriptor so that metrics are collected. So it continuously goes to the common DB and asks, I think that the default is every 30 seconds. It looks for metrics that are requesting, VNFs that are requesting metrics. So then if it finds a descriptor that it needs metrics, then it goes to the VIM, collects these metrics, and stores them in Prometheus. How? Well, it exposes them in a component called exporter, which is basically a Prometheus way of storing metrics in a temporary way so that Prometheus itself can go and collect them. The way Prometheus works is by going to these targets, to use the Prometheus concepts, and it goes to these targets and collects the metrics that are in there before they are replaced, because they are updated all the time. MON is not storing these metrics directly. It exposes them in a Prometheus format temporarily, and it keeps replacing them, and Prometheus is the one responsible of querying all the metrics that MON is exposing, or this exporter in particular. And that's the way that Prometheus stores, and this is also a database, so it stores all the metrics in a cumulative way. And then Grafana can read and present these metrics accordingly. Okay, so this is the way that you can achieve matrix collection when the metrics relate to VNFs. Is just MON. Well, you just need to model your VNFD accordingly to say which metrics you want to monitor. They are normalized. The keywords that you need to use, and then MON collector will take care of the rest. It goes to the VIM, collects the metrics, stores them temporarily in the exporter. Prometheus goes and grabs them, stores them permanently, and then you can produce your dashboard in Grafana. When you're collecting metrics from a VNF, I mean directly, without passing through the beam, and you want to log in the VNF or consume an API of the VNF and get a KPI that is specific for the VNF, instead of going and asking the beam for it, I need to correct this, it goes to VCA, because nowadays we are using UU metrics from VCA, which is a way of collecting metrics continuously using UU. So it's a sort of charm that runs continuously and collects metrics every 5 minutes. But since it's fixed every 5 minutes, we are trying to evolve this to a different method, which would be to implement an independent exporter for VNFs. But before that, this is the way it works. Instead of MON going to the beam to collect the metrics, it goes to VCA. And of course, you need to previously have built a charm that goes and runs commands in the VNFs to expose the metrics in the UU metrics way, and MON goes and reads them and stores them in the exporter, and Prometheus does the same. Alarms and autoscaling. So I mentioned before that there is a policy manager. This policy manager component has two options, two implementations today. So let's see. If you have alarms configured in your descriptor, what MON does through its MON evaluator component, it looks for these alarms that are stored in CommonDB, because when you model a descriptor with anything, that information goes to the CommonDB. We saw that before, right? So MON goes continuously looking for alarms configured at the VNF record. And if it finds alarms in CommonDB, then it queries the metric values actively, continuously, goes to Prometheus and looks for these the metrics that are being associated to each alarm. And if the threshold is crossed, then it depends. If the alarm was configured just for notifying a webhook service, which is one of the implementations we have, then Paul launches this notification to the webhook service. But if the alarm was looking for scaling in or out, then it goes and puts a message that LCM consumes to instantiate a new network function or the scaled virtual machines that are needed. So again, it depends on how you model the VNFD. MON evaluator, what it does is compares the value of the metric that is in the alarm with the actual value, and if there is a threshold crossing, then it triggers scaling or it triggers a notification. Then we have a new service which is called a MON dashboarder, which is sort of a prototype in Docker Swarm installation, which is being ported to Kubernetes soon. What it does is it continuously looks for new projects in OSM or new network services with metrics. And what it does, it creates a dashboard in Grafana automatically. So you create you have, for example, the admin project. Then you will find an admin project dashboard in Grafana, which lists all the network services you have, lists the VIMs you have, lists the status of your network services and everything. So it continuously deletes obsolete dashboards in case a VNF is deleted. And it also creates a default network service dashboard with sample graphs whenever a network service is created. So this was added to enhance usability of metrics in OSM, so that you don't have to go manually look for them at MON or Exporter or at Prometheus API. You can just visit Grafana. You don't even have to create your own dashboards. It will be automatically created. Okay, so those are maybe the main operations in OSM, and what we wanted to do is provide to provide an overview on which components do what in OSM. This is open to suggestions, to enhancements, because we would like to cover most scenarios and in the most accurate way. And this is useful, as I was saying, for troubleshooting. So don't forget that a general approach for troubleshooting in OSM when you receive an error in anything, I mean, in the Vim, in a network service, is to show the instance. Use the network service show, use the Vim show command, because those commands give you usually the details you need for knowing what's going on. Besides that, since you already know with the diagrams already presented which component does what, when you are launching a network service, for example, and you receive an error when launching your network service, you should know that you launched your call, the NBI should have received that call and should have sent a call to LCM. So the first component I would look into, it would be LCM, right? And if LCM shows everything okay, then I would go to RO, which are the main components in the path to instantiating things at the Vim. So LCM, then RO. And that applies to anything else. So what I was saying is, knowing which component do what, you can troubleshoot by looking at the logs of each Docker container or each pod in the case of Kubernetes installation. So be sure you visit this section here, the user guide. The user guide is trying to gather most of the problems that the community experiments. So if you see anything here that is missing, just let us know. You will find here, for example, about logs, QU logs, so that would be the VCA, and you have Docker container logs. You can see how to change the log level in the Docker Swarm installation. At the end, just send an email to the community to get someone on it. So that's it for this section. And before switching to the installation methods and installing OSM yourself, do you have any question? I'm going to the chat now to see. There are a lot of questions. So related to the authentication using Keystone, when you use it, does it only allow you to use the resources that the user has permission to, right? Yes, when using Keystone, you have a policy file by default in Keystone. So it's already populated with the most common roles or tasks per role. So, and they are already 3 or 4 predefined roles in OSM. So there is admin, there is a project admin, there is account manager, there is an operator, I guess. So there are already roles in there in OSM, and this is independent from Keystone. It can be also with internal database of authentication and assignment. You have these default roles. So when you assign these roles to a user, no matter if the user resides in a LDAP backend or in a local backend of Keystone or in the local backend of OSM itself, then you have the right permissions. Another question is, action to notify a web service implemented? Yes, it is implemented. For now, you need to define your webhook service in the descriptor. That's documented in the monitoring part. And when you fill that up, policy manager will take care of sending the alarm to the webhook service. There's no subscription service yet in NBI. There is already a feature for that I guess it would make it to be the same. For now, it's just I would say proactive notification to a given service. That's OSM support subscribing for change notifications or inform the subscribers about configuration alarm performance. Not yet. That is being proposed for the next major release. So not subscriptions yet. Okay. Any other question? How does OSM perform BNF auto-scaling or automatic actions? For example, service restart when service stopped. How to make configurations of automation for auto-scaled BNFs? That's a good question. So yes, nowadays OSM supports the auto-scaling of BNFs of per VDU. I would say per VDU auto-scaling. So based on metrics, whenever a metric threshold specified in the scaling descriptor is crossed, then policy manager takes action and puts a instruction in the bus so that LCM goes and scales out or scale in a VDU or a set of VDUs, BNF components. And that's what is supported today. So what we're working on is on the charms that can be triggered for scaled instances. For example, you may want to scale a new component of your BNF and then would like to configure a load balancer, which can be a PNF, and say the load balancer, hey, you have here a new instance added to your list of services. That would be a primitive that would be triggered by the scaling operation. That is not supported today, but it's already modeled, so it would be just a matter of adding the relevant code. I'm not sure if it has a feature request yet because we haven't had a lot of demand for that, but I will write that up because that's an important case, and it has also been asked at the BNF onboarding task force. So not supported yet the scaled operations. I mean primitives after scaling, but definitely a relevant use case. Any other question? Okay, I'll leave you with Cyndi Alarcon.
Yes, well, hi everyone. Just 1 second to share my screen. Okay. Well, hi everyone. This is Cyndi. I'm from Whitestack. My role is cloud engineer, and in this part of this session, I'm going to talk about the different methods we use to install OSM. So first, we have to know the main requirements to install OSM in just a single host or a virtual machine. So we have two options. The minimum option is to have a virtual machine with at least 2 CPUs, 4 gigabytes of RAM, 20 gigabytes of disk, 1 network interface with access to the internet, and we will use as an operating system Ubuntu Ionic. And we have another option that is the recommended option, that is using a VM with 2 CPUs, 8 gigabytes of RAM, 80 gigabytes of disk, and 1 NIC with internet access, and also using the operating system Ubuntu Ionic. Okay, so once you have prepared the host with these previous requirements, all you need to do is just to download the installer with the OSM release 7 and make the installer executable. So with these steps, we're ready to start our installation. For installing OSM, we offer two main options. The first option is to run using Docker Swarm, and this method we were using during these years, and we have released a new method of installing OSM over Kubernetes. This is released in this Hackfest with OSM release 7. So installing OSM over Kubernetes, we have two options too. That is listed below. We have the default option with a cluster of Kubernetes, and we have another option using UU charms. So if you want to know or get more information about the different method options we have for installing OSM, we have official documentation at this link that we show you now. So this is an important site where you can have information we are updating for OSM release 7. Here we have the default, the main requirements for installing OSM. We also have different options if you want to use a Vim emulator, if you want to enable full management features. Also, we have documented the way we install OSM over Kubernetes, how you check your installation after the process of installing, using Docker Swarm or using Kubernetes, and how to see the logs, and more information about integrating with Vim account that will be seen in the hands-on later. So this is a good site to start using and testing our OSM platform. Okay, this was a summary of our main installation method. Now, what we have is the first hands-on, where we're going to install OSM over Kubernetes. So here in this slide, I'm showing the scenario of our installation over Kubernetes. Here, we will deploy OSM in a single host running a single Kubernetes cluster, as shown in the diagram. You will install OSM over Kubernetes in the virtual machine that will be that is created already in your tenant. We will have to download the installer. And then this installer will install different packages to run a single node Kubernetes cluster, and it will deploy the different objects on it. So inside this cluster we will deploy, there will be three main namespaces or virtual clusters. We will have a kube system namespace monitoring that will be enabled in the later, and we will have the OSM namespace. Inside each namespace, we will have pods created, and inside each pod, we will have a container running on it. And then we will have to test our user interface of OSM in order to explore the different options we have, and we'll be testing different features later in other hands-ons. Now we have to enter to our tenant and then try access to the VM, the virtual machine that is created through SSH. You have to use the user Ubuntu and the password OSM for you. So just let me know in the chat if someone is having trouble with this. So here I just download the installer and I made the installer executable. So now I'm going to run the installer, check that this command have the option -c -kas. This is to tell the installer to run OSM over Kubernetes like a container framework. So I'm going to run this script. So the process of installation is starting. So we want to wait some minutes. Just to tell you that for this last session, we have a pre-configured virtual machine because we have to download the different Docker image and also that in order to accelerate the process of installation. In a normal installation, it would take like 15 minutes. So in this time, for this last session, this installation will take less than 5 minutes. So during the process of installation, we will be asked to confirm if we want to install all of these components. So we just say yes. Okay, and wait until the script is finished. So to know if the installation is finished, we will receive a message at the end that says done. So right now we're going to check the Kubernetes installation first, then we're going to test the OSM client, and finally we're going to access to the user interface of OSM. So first we want to know or explore how the Kubernetes cluster was installed. So for this we're going to use this command kubectl. This command talks to the Kubernetes cluster to get information and to execute different actions. So first we're gonna see how many nodes we have. The result is expected that we have only one node that has the role of master, and the status is ready. So we have some knowledge that at least the cluster of Kubernetes is stable. So right now we're gonna list the namespaces created in this cluster. So here we see 5 namespaces, but in the previous slides I only mentioned 3 of them because the namespace default, kube no list, kube public, we don't use it, but are created by default as the kube system. And for OSM, we need a namespace. We have configured this namespace because there are created all the components for our OSM platform. So if we want to explore all the pods that are created in all the namespaces, we execute kube get pods all namespaces. In this, with this command, we'll have all the information of all the pods created. For example, we only have pods created on the namespace kube system that are pods that have all the resources for the administration of the cluster. And we have different pods created on the namespace OSM. We have Kafka, Keystone, the user interface, Mongo, MySQL, Prometheus, and different other pods that we have that is necessary to run OSM platform. So if we want to get detailed information of the resources created in a namespace, we can execute kubectAll in the name of the namespace. For example, if we want to know all the information about the namespace kube system, we run this command and we have information about the pods that are running, the state of these pods, and also the service that is created, and more information. If we want to know about all the resources created on the OSM namespace, we execute kubectAll -n OSM, and we have all the information of the pod created, that the status are running. We have the name of the services created, deployments, and for example, we have information about some services that are exposed. For example, the user interface is exposed to the 80 TCP port number. So later we will want to check this access. And if we want to have a specific information of information of a specific pod, we can get that information with this command kubedescribe pod. Here we enter the name of the pod, and we have to indicate also the namespace. So in this case, the name of the pod is different in each scenario, so we have to replace this name. So for OSM, the pod for the user interface is this, so I just copy that and execute this command. So here we have different information about this specific pod. Also, in the last part of this output, we have the different events, since how the pod is created, and finally it finished with the starting of the container that is related with the user interface. Okay. So this is so just some commands in order to explore and to check if the Kubernetes cluster was installed correctly. Now we can test the OSM client in order to interact with our OSM platform. So first of all, we can test with this command OSM-help in order to see all the options we have for this OSM client. So if the OSM client was installed correctly, you will have to get this information. Okay. Now we're gonna test a command. We're going to check the user created in this platform. So just execute OSM user list, and we see that we have only one user created, that is the admin user. So if you're not having problems until this, it seems that your installation was correct. So I hope most of you have this result. Okay. So the last part of this hands-on is to check the access to the OSM user interface. So for this last step, you have to go to this address. Just replace replace it with the IP of your virtual machine. You just use the admin user, the password admin2. So here we have the OSM platform, the user guide. Here we have different options to create network services instance, to add some Bing accounts and more options that will be exploring in the next hands-on. So I guess this was the last step of this lab session. So if you have some questions, you can use the chat. Okay, so I see most of you got access to OSM. So, well, this lab session has finished, and we return with the session of monitoring in OSM.